Here's example 8. We have a baseball player who hits a ball, and it goes up into the stands, and it's caught by another physics teacher. The ball was caught 7.5 meters above where the ball was hit. And, because it was a physics teacher who caught the ball, he noticed that the ball came in at an angle of 28 degrees at a speed of 36 meters per second. So let's take a look. Let's take this and let's expand it out. Alright, so here's the... So now when the ball came in, it had a speed of 36 meters per second. So that's its when he caught it. And it came in at an angle of 28 degrees. So now, the question then is, how fast did the ball leave the bat? So that would be right here. So this is a really poorly drawn bat. So here's the ball. When it comes off, it's going up at this angle. That would be the initial velocity. How fast did the ball leave the bat? So now let's break this up into our directions, into our x and y positions. So let's start with x. Our initial x position is 0. So we're starting here at x initial. We're going to call that 0. Oh, we need some directions. We're going to call this way positive and this way positive. X final. Where does it land? Somewhere over here. Not sure what it is. The initial velocity in the x direction? Well, it turns out that's what we're looking for. We need to find out our initial velocity in the x direction here. Something we're finding out. Let's keep going. What about our final velocity? How about this? Final velocity in the x direction. Oh, well, I know the final velocity over here. The final velocity in the x direction is just going to be this part of it. This is my final velocity in the x direction. So my final velocity in the x direction, if I remember so here's the angle, that's the adjacent. So the cosine of 28 degrees is going to be the opposite, or the adjacent, v final in the x direction over the hypotenuse, which is 36. So my v final in the x direction is 36 cosine 28 degrees. If you do your math, that turns out to be 31.786 meters per second. Yay. What's my acceleration in the x direction? We are in free fall. We are in free fall, so the acceleration is 0 meters per second every second. My t initial, I start at 0. My t final, I don't know what it is. Well, let's see. Can we figure out what our initial velocity in the x direction is? Well, let's take a look at our equations. Ooh, I think I like this top one. I'm trying to find out what the initial velocity is. So, initial velocity plus the acceleration times the time equals the final velocity. We are in the x direction. V final in the x direction. My initial velocity is what I'm looking for. My acceleration in the x direction is 0. I don't know what the time is. My final in the x direction is 31.786. Oh, look. That goes away. My initial velocity in the x direction is 31.786 meters per second. Yay! Now we need to find out what the velocity in the y direction is. So if we go back to here, this is going to be my initial velocity in the y direction. So let's see if we can figure out what that is. What do we know in the y direction? Our initial velocity, our initial y position is going to be 0. Our final y position is going to be plus 7.5 meters above where I started from. So, because I catch it up in the stands, plus 7.5 meters. My initial velocity in the y direction, that's what I'm looking for. My final y direction, I think I can figure it out from here. So this is going to be v final in the y direction. That's the opposite angle, so let's use the sine. The sine of 28 degrees is the sine of this angle is opposite to v final over y over hypotenuse, which is 36. So v final in the y direction is 36 sine 28 degrees, which is 16.9 meters per second. V final in the y direction. However, notice it points down. Our positive in the y direction points up, so this needs to be in the negative direction. Next, our acceleration in the y direction. So this is negative 16.9 meters per second. We're in free fall, so it's falling at g. G is pointing down, so it's in the negative direction. I'm going to round that to 10. And our time equals 0, and final equals I don't know. So we need to find out what the original velocity is. Well, we could try this one again. V naught. Let's change colors so we can see what's going on. V naught in the y direction plus my acceleration times time is going to give me v final in the y direction. V naught y equals plus negative g times t equals v final in the y direction, negative 16.9 meters per second. I got two unknowns there. I don't like that one. Let's move on. Since I don't have my time, let's use something different. Let's use this one. So, v initial in the y direction plus 2 times my acceleration in the y direction times my delta y is going to give me my velocity final in the y direction squared. This one needs to be squared as well. So, here we go. P initial y squared plus 2, my acceleration in the y direction is negative 10. The change in y is 0 to plus 7.5. That gives me a plus 7.5 meter change. And my final in the y direction is negative 16.9 meters, negative 16.9 meters per second. This needs to be squared. Here we go. V initial y squared plus 2, this ends up being negative 150, and this equals 285.61. My initial velocity squared equals 435.61. Take the square root of both sides. Initial velocity in the y direction is 20.87 meters per second. My initial velocity is in the positive direction. Now I have my initial velocity in the y direction. I have my initial velocity in the x direction. It's right here and right here. Now we can go back to our original problem. I have this one now, so my initial velocity in the x direction is 31.786 meters per second. My initial velocity in the y direction is 20.87 meters per second. 20.87 meters per second. I have a beautiful right triangle. Now let's use a little bit of our Pythagorean theorem to get us where we need to go. That's so a squared v initial x squared plus v initial y squared is going to give me v initial squared. A squared plus b squared equals c squared. 31.786 squared plus 20.87 squared is going to give me v initial squared. 31.786 squared is 1010.3 plus 435.61 v initial squared. 1445.96 equals v initial squared. Take the square root of both sides, and our initial speed is 38 meters per second.